I'm Professor Nicola Morley. I'm at the moment the head of department of Material Science and Engineering. So my research is based on functional magnetic materials. I get work from the very simple magnetic films. I really enjoyed physics, and I did my undergraduate degree was in physics, and then I did my PhD in condensed matter physics. So when I finished my PhD, I wanted to do something that was more useful, and I started a postdoc in magnetic thin films, trying to understand how the behaviour of a film changed when you put it onto a substrate, and I just grown my research from there. Actually being able to build something or create new magnetic materials that are going to benefit society, and that's something I find really fascinating, and something that's been the heart of what we've been trying to do in materials for the last 10-15 years. I've gone from trying to make the best material I can independent of cost to actually, can I find solutions that are going to save the planet? And it's something that I find really, really interesting, the whole sustainability and creation of new materials.
I'm looking at magnetic materials on surface acoustic wave devices. Yeah, so I spend a lot of time doing fabrication of devices. So the SAW devices themselves are a little bit tricky to make. So it's just a series of interlocking fingers that produce a wave when you put a voltage across them and things like that. And then we were just trying different materials in between these devices and seeing what happens. I just enjoyed science at school. I was quite good at it, like maths and physics. And so it felt like the obvious choice when I went to uni. When I was in my fourth year, we had a lecture course on magnetism and superconductivity, and I just loved it. I just thought it was great. And so I ended up looking for PhDs in a related field.
So I'm designing new materials for 3D printing, specifically for high temperatures. So hopefully some of my materials might end up in the future, very far in the future, might end up on a jet engine or something like that. So hopefully designing new materials for the next generation of jet engines will enable them to be much more efficient than the ones we have now. Also, the manufacturing process, 3D printing, allows you to use exactly the amount of material that you need for the part that you're making. Rather than machining down a big block of material, creating a lot of waste, you can just use exactly the amount of powder that you need to create the part. So it means that we're not cycling through loads of material rates to create these aerospace parts. So it's much more efficient.
My name is Xingyue Chen, and I'm the experimental officer of the Nanocharacterization Lab. My daily job currently is mainly to provide the expert guidance and trainings for all sorts of internal and external users. I did a theoretical physics degree and then moved to biochemistry for a master's degree. Finally, a biophysics as my PhD project. So it's very interdisciplinary. I'm normally confident about myself, so I guess this might be a tip there. If you want to do great science, and forget about the gender difference, and be strong enough. But I do realize there is definitely stereotype in the field, because I did physics degree, and I remember in my undergraduate class, there were more than 50 students, where we only had 4 female students.
So I'm a PhD student here at Sheffield University, and I'm work primarily in metallurgy, and within that I'm looking at the brazing, which is a joining method of 3D printed metallic parts. So my research is funded by the UK Atomic Energy Authority, and they're looking at delivering nuclear fusion as a source of energy. What I'm looking at is using 3D printed parts, getting them to a place where they can be used within the main plasma-facing parts of a nuclear fusion reactor, making sure that the joints within that are sound. My family has always been quite science-driven in general. I also know that I had some amazing teachers that really inspired the chemistry bug in me, and it was a subject that I thought there was a lot of potential in, and a lot of the stuff is sort of like thinking in 3D shapes and how that all works. There's so much to say, because it is just about backing yourself and being willing to put in the hours and accepting that you have a place at the table.
I'm Corinne House. I'm the Operation and Project Management Lead, so I look after the Royce Institute in Sheffield. I manage the facility, which is health and safety, looking make sure the building is operational, so people can come and use it. I liaise with all the technical staff here in terms of the ground management, and also manage all the access scheme. Yeah, a bit of everything. I started by actually doing chemical engineering, then I moved on to chemistry, then I moved on to polymers, and I finished really, and my PhD was more in kind of polymer physics. And then I basically said to go into industry, and I worked for a company as I was a researcher in a large steel company. As I grew into being more senior, then I started to do more project management, and that's why it led me to actually come back to academia. I'm a mother of two. I juggle my work and the family. I think that women in science and engineering are very important because of their diversity. We think differently, we do think differently than men, and I think we need to encourage young women to join us.